Nice to see you all back in this webinar. Most of your guys been already enjoying the last webinars, as I can see from the list. So today we were gonna talk about the VR headsets, how to get them into Ventus, how to use them in Ventus, how to use the controllers and stuff like that. But the basics is how to get that things up and running and prepare the stuff for Ventus so that you can make use of the devices. The first thing you would need to have is Steam installed. Um, the reason is that we are using the OpenVR platform, and this is basically offered by Steam VR, and therefore you need to have a simple account created on the Steam website. I'm gonna change that to English. Uh, I know as Espanol is also working for some of you. So here we go. So this is the English web page of Steam. Steampower.com is a website you have to navigate to. Then you install Steam here and download it. And all you need to have is then an account created with any kind of name. So the next step, what would be needed is to install Steam VR. As soon as you connect your headsets to to Steam or to your computer, it's gonna ask you to install the Steam VR stuff. And after you install that, you have to run through the setup and either create a standing or seated experience or a room scale experience. The differences in the first that the measurement of the headset's position and so on are differently in first. And another thing is, I don't know if we changed that for now, but also the screen orientation inside of Ventus is affected by these settings. That means when you have selected, for example, the seated experience, you're looking direction north. If you're using the room scale, you're looking direction south. This could still be the fact. I don't know exactly. I would need to change that and check that in the end. I didn't take care of that. But that was the times when I used Steam VR and the headsets with Ventus. As soon as you have done the room setup, it's called the room setup for Steam, you are mostly done with the critical parts, but we need to ensure to have Ventus recognizing the headset. This is to be done by using the configuration editor. By the way, don't worry, we are recording the session, and the session will be available on YouTube later on whenever a colleague of mine has finished the cuttings and inserting logos and stuff like that. So we will announce on our page or sometimes also in the forums and so on where to find the video, Facebook and so on. And this is just a hint. We have also a Discord channel, we have Facebook pages and so on. You can pay us a visit there anytime if you want to. So let's continue with the Ventus configuration editor and bring the headset to life with Ventus. The point is you just need to change or create a setup for the audio, video, and hardware device mapping. You do so by clicking this plus here to create a new configuration, and we call this VR webinar. So click OK. And the next dialog I'm gonna skipping now. This is where it asks me where to output stuff. And I just need to simply drag and drop the OpenVR icon into the outputs area. You don't need to configure here anything. Just click OK, and that's it. You have some settings available here, like the multi-sampling and so on, which plays a big role if you're just using the runtime instead of the editor. You could change these things by the live options in the end, just for info. The FPS should be set to the 90 for VR. This would be our goal because we're using 45 frames per eye. this can be left like it is, like 60, or you use these fixed 90 frames. But another very important thing is the frame rate multiplier. By changing these values here, you can see that it runs at X times the internally set frame rate. This is sometimes important if you're using two different computers. The one should show and use the wife, and the other one is like a spectator. And you need to make sure that they are both running on the same frame rate because of the movers, because of the video playback, and so on and so on and so on. Therefore, you would need to adjust the frame rate multiplier here in the config. But you can read through all that in the documentation of Ventus. All we need to do now is we're gonna save this configuration, exit, and we're gonna start up Ventus now. I've prepared already a project, and this is how Ventus looks like when you have the Vive connected and when it's running. You see that the orientation of the screen has changed, of the renderer window. That's the reason, because the displays internally of the headset are rotated by 90 degrees. So it's not like you have a 16 by 9 screen, you have more or less a 9 by 16 screen. So it's really rotated counter or clockwise. So the preview for any customer or client would look the same. And by the way, this is just one of the both eyes you have available. So another very interesting thing is our log. Here you can find useful informations about the devices which are right now connected to Ventus. Since I'm using the old HTC Vive and not the newest generation, nor the other Vives or whatever else, or an Oculus, we're gonna read here that I have two lighthouses, which are named like the reference, lighthouse reference. And then we have two controllers for the left and the right hand, and we have the HMD. This is the HMD is basically your helmet you're wearing or your glasses, short form for a head-mounted display. These are the things I take care of. I'm looking at if I encounter any kind of problems, like tracking is not working properly or something like that. The other information is that you can see the device IDs, and these IDs can, you can make use of them later on when you want to assign to render the lighthouses inside of your Ventus scene, if you want to draw the controllers, and so on and so on. So this is a good hint to see that. The next thing is, if you're using, for example, an Oculus Rift, you're gonna see that these things are changed to Oculus Controller, Oculus Lighthouse, I think, and all the things. So, and this is a difference when it comes to the message log. So when I now throw a cube with an axis into our scene, you can see that my headset, I'm moving now my headset around. You can see that the tracking is working, and yeah, basically no big deal. You don't need to create a camera, a custom camera or something like that. You don't need to switch the camera to be used by the tracking system or whatever else. It's like running out of the box, and that's a cool thing. So basically the webinar ends here. That's all I need to show you. No, I'm kidding. There is much more to discover. So, but you see, that's quite easy to have everything working out of the box by just creating the configuration, save the configuration, firing up Ventus, and Ventus automatically recognizes the headset and is making use of the tracking, as long as the base stations are working and everything else. But this should be already checked and done whenever you have created and used the room setup. Another very cool thing is, let's use the toolbox. So I can show you all the available stuff we have for VR. We have three categories in this case, or subcategories, the ones are the tracking devices, track devices, the other is draw track device, and the third node available is a draw touch ray. So when you right click for the tracked device, you can see that we are using the tracked reference, tracked Odyssey, Oculus Controller, Vive Controller, and the tracked HMD. The other controllers for the newest generations of Vive HMDs are not shown here right now. The glasses are the HMD is working out of the box since we are using the Steam VR, the Open VR interface, but it might be possible that these controllers have special triggers, buttons, events, and so on. They have their own design and so on. If you are using such, it would be nice if you drop us a line. We would try to implement them if you really need them. If they are not working, sometimes it's happening that Steam is updating internally their stuff, and also the standard Vive controllers and the Oculus controllers are not really working anymore since they changed internally some stuff. If that occurs or if that happens, just drop us a line at support@ventus.com or use the forums, create a post there or a thread there, and keep moaning about that it is not working, and we're gonna try to implement the newest version then into Ventus. The bad thing is, on the other hand, we don't have all the devices available, so we cannot verify that this is really working. For the basic stuff like the Oculus and the Vive, the first version of the Vive, we can check, we have the hardware available, but we don't have the Oculus S or whatever else available. We just have the first models of all of them. So that's one of the reasons why we don't have implemented that. The Odyssey is for sure because of the Odyssey headset. So much about these tracked things. So tracked reference, tracked Odyssey, tracked Oculus Controller, tracked Vive Controller, and tracked HMD is basically, as you can indicate by the small symbols here in the icon area, they are more or less like an axis. So when I drag and drop now my Vive controller into the hierarchy, I can, if I turn on my controllers, as you see, they are turned off. So first is on, and the second is on. So, and you can see, is it deactivated, this is activated, and so on and so on. So let's go through the properties of the controllers. Let me check. This is the right one I have now in my hands. So you can see we have an ID here. When you open up here the properties of the Vive controller, we have an ID here. This ID is now set to 0. This is the very first tracked controller I'm using right now. So we have this aside here. I'm now enabling the second one. I just put it on the right side of the first controller, and I switched the ID to 1, and you see now it's the other one. So this is what you basically need to do. Either you copy that node if you want to use both, increase the ID, and you see you can have both controllers. The neat thing is, as you can see, all these reactions to the buttons, to the triggers, and so on are also taken into account when you have a look at the geometry. Another thing is you can also make use of the pad positions. You can see that small sphere here moving around because I'm using my thumb to adjust the position on the trackpad. Okay, back to the toolbox. As you can see, the tracked devices got now also drawn on screen, but we have another bunch of nodes that enable us to draw the controllers, also draw the HMD, which is kind of interesting if you have a secondary computer attached to that, and you are having a spectator view of the whole scene, and you can see the HMD walking around then on the secondary machine. So the first user or customer is enjoying the experience in VR, and you have a spectator machine on the side, and which shows the whole environment and the guy walking around and the controllers and so on. This is kind of funny, which is also be used for debugging, that you see the actual position of your VR headset. So then we have the draw touch ray, and the draw touch ray is, like it says, it's really drawing the touch ray, but you can change the appearance by using that node behind the controllers. So this was another hint. Since I mentioned already, this is an axis. Everything you put behind will be attached to the controller. Yeah. So I have here now my right hand controller. It's the correct one, yes. And I'm just simply putting a sphere behind that controller and position an axis, because the sphere should be too big right now. So here we go. And as soon as I move now the controller, the sphere seems to be attached to the controller. Another thing to mention is you have different kind of touch methods inside of the properties of the controller. For example, if you're using the volume, yeah, the volume is really where the sphere is positioned at this position here, at the let's get it a bit smaller, like 0.2 there. This is the volume area. It's really just a simple small space. I doubt we can change the volume. Oh, we can. So that means if you want to touch letters on a keyboard, for example, by using the volume instead of a ray, which is shooting directly towards the controller direction, if you want to use the volume, you need to take care that this is the reactional position of your volume. So whenever you hit a virtual keyboard, you must make sure that this volume is really touching the keys. Yeah. So anything that can be touched or has a touch node in front is reacting only at this point, nowhere else, not inside of the ring or whatever else. It's really that position here, the small position. My headset is drifting away. So so much about the touch method using a volume. The good thing is about these controllers and Ventus, and that's difference to all the other tools available outside, we have made all connections available for you. That means you can use the pad float numbers, you can use the trigger as an Boolean or an int float value. You can also read out the battery. You can get which kind of trigger is pressed, if the D-pad or the trackpad is touched, which button here, the top button is pressed, and so on. All these things you can make use of. So, and the same goes as events. So you get all the events out, that you have the trigger, enter, leave, that you have the side grip, begin and end methods and stuff like that, the D-pad and so on, and that you are using it, that you touch it with the thumbs. All these things can be used to control or interact with your scenes, which can lead into an amazing possibility to have a real cool menu created for your controller and stuff like that. Another thing we have since some versions is to have the vibrate function. This is like it's really short impulse which is sent to the controller. We have no big influence on how these vibrations, how long these are. So you would need to connect a logic here that repeats, for example, the vibration press button to have a really high impulse vibration or something like that. Another thing is to use the draw function, and this is important later on if you want to texturize this controller. So much about the basics thing of these track controller node. I've created a simple controller already, which we'll make use of now. And this is the first one I have here on my side. So one thing that is kind of a bit bad when you want to design things or create things for the controllers or something like that is that you have always to move your headset to get a proper view of that and so on. But we can also put the headset aside for that moment. Use our free fly camera. and fly around. So you see that we have kind of distortion here. The simple reason is this is used by the shader of the headset. This is like a fisheye lens distortion we have here. Okay, so I have my controller here, and I have now set everything to the defaults, like infinite ray. The touch trigger is the trigger and not the trackpad or a button or something like that. So that means whenever you want to interact with some geometries or touch buttons or something like that, it will take the trigger event as a touch interaction, the same like if you click with the mouse button. Yeah, the gravity and range we're going to change soon, and the ray only untouched is an option which you can enable to have, for example, this ray shown. And we are using now the infinite one. That means it goes really 1 million kilometers far into space. So whenever it hits a surface which is touchable, then it can react on that. So this is here the option ray only untouched. If you are working on the ray, for example, you want to texturize the ray, is a wise option to set this boolean to not true, and then you see you have the ray always visible. Then you can change, for example, to a limited ray. The limited ray is now controlled by the range, and the gravity is taken into account when you're using the parabolic one. Parabolic means it's really creating an arc, yeah, and you can say how much gravity affects now this arc. The good thing is whenever you're moving this controller to the left and to the right, you see that arc is constantly pointing downwards, like it has gravity enabled. That's the reason why we say touch gravity. You can then change the range, and you see it will really create an arc. Another thing where you do not need to wonder is whenever you have the controller pointing upwards, like it's like 87 degrees, 85 degrees upwards, the touch ray will disappear. This is done by the Vive controller or by OpenVR. This is done by their software. We don't have control over that. It's like they simply disable the ray. I don't know why. Maybe, I don't know. So another thing is that you want to change sometimes where the ray starts from. Yeah, especially when you not draw the controller, you have your own I don't know, your own geometry for that. For example, a really cool cube is used for that. Then you want to adjust where the ray comes from, and this can be done by changing the matrix, the ray matrix. Let's say this is kind of, I don't know, a box of fanciness, and the ray should come out here. Then you would adjust the matrix, the ray matrix for the track device, and change the translation to have it here, and it starts basically there. So this is the ray matrix. Yeah, so you can alter all the values there. Okay. Like I said, I want to change the textures, for example, and that's why I have this now enabled, that this ray is not only when I touch like the trigger or D-pad or something like that. So have a look when I'm now using the trigger. Where's my camera? So when I'm using now the trigger, it doesn't show up the ray, but as soon as I touch the D-pad, it shows now the ray. So this is, by the way, the touch trigger you have here. So, but I want to colorize or change the appearance of this ray. I created a simple texture, an alpha texture, have no light, and the base color of look like bluish, and animated just the position of this texture. So this ray is like having a forward gradient moving around. Here you see I'm just animating endless, infinite the position Y. I've just changed the scaling for this texture to be small like that. So whenever you put a material in front of this draw touch ray, and that's the reason why we have this node available, is to colorize or change the materials, for example. But you can also change diameter of this ray. Yeah, you can change the segmentation of that. You can say, I don't want to have the body drone. I want just to have the caps, which is here and somewhere down there. And you can also change the ID, and this is important. So whenever you use the draw touch ray node, you need to change the ID to 1 for the secondary controller. Else you're gonna wonder why it's not working. Another very important thing is to have control over the touch groups. And first you're gonna think, oh, for what? The idea is you have 2 controllers. You can then define to say the left controller is only using controls for specific interactions, while the right controller is just for teleportation, for example. Yeah, then you would change these groups. You say for the left controller, the ABC group is available for it, and also maybe the default, and for the right hand controller it's just D, because D is using for the teleportation used for the teleportation node, which we go into detail later on. So, and here you say the group filter is just for D, and then it reacts only when it gets touch from the touch group D. So the right controller only is the only one which works for that. Keep in mind you have sometimes left or right-handed people, so maybe you need to switch the controllers. Then you just put it in another hand, but you need to tell them if you are used to navigate with the left hand, you should have the secondary controller in the left hand then. So far so good. So texturizing of a draw touch ray is quite easy. As you see, just a material in front of it, and there you go. As I explained already, you just need to hook up your geometries, your textures, and all that stuff behind the tracked Vive controller node, and the menu, for example, I've created here, which has basically no function. The menu is now showing and sticking to the controller, which is quite cool. We could use now the first controller using array and also adjusting these color picker marks here because they are touchable. We will do so in a second. But let me continue with the other stuff here. We can simply make use, for example, of the alpha fade, yeah, to fade in and fade out the menu by using a toggle function and the linear. The linear is now like if it's use target 2, then fade it in. If it's toggled, then fade it out. So this is a very, very simple logic I've created here. So we connect it to the toggle. The toggle is now set to off, and the toggle itself is bound to the Vive, and it asks me now what button we want to use, and I could say, okay, let's use the let's use whenever we enter the trackpad. So whenever I push now with my thumb on the trackpad, it shows the menu. Or we can use a different button, I don't care. So let's use another button, a different one, which is the sides, which is grip. So whenever I'm pushing now the grip, which can be seen here, I'm pressing it and it reacts. So then it shows the menu. Quite an easy, absolutely. Another thing which is quite cool is we want to have this array. We can limit this array as we have seen, yeah? So let's check it here. We have the range. We could change the range. The same goes for the limited array. We could change the limited array range. I would like to use now my D-pad to increase or decrease by the pad Y value to increase and decrease the length. I've created a small node for that. I'm binding that now to pad Y. This is my input. And the output you can see here is increasing when I have my thumb there on the top to maximum of 5. And I can decrease it down to 0. So let's bind that one to the touch range. And now, whenever I use my D-pad, I'm going to increase or decrease my ray. And the same goes for the parabolic. Erp, erp. That's a cool function, right? I wonder that no one is asking me where to download that node. Inside of this container is a bit of logics. And to be honest, I needed some help from Steven. He introduced me, and I was asking a long time ago for what's the use of the loop breaker node. And this is the first time I've ever used the loop breaker node, therefore. So, and he created that kind of small logics to make it like whenever a tick is happening, it's increasing a value by a given number with a delay and so on and so on and so on. So we have 2 frames delay, and then the float got increased, and so on. It's working based on the frame numbers. So, and that's a way to have this ray increasing a value or decreasing a value. Yeah, this is the simple logics. Don't worry, I'm gonna upload that if there is enough demand for it. Nobody's asking till now. I'm gonna upload that later on our OneDrive that you can download that. So basically, this is very easy to create cool menus therefore. So you can imagine what else you can do quick and easy with Ventus by just using all the events and methods available. For example, if you want to have the battery visualized, how much charge is left in the battery, you just need to have a cylinder, for example, an axis to position it somewhere else where we're gonna see that guy. So the size is too big, something like that. Here we go. Then the alignment is bottom. Is it bottom? It should be bottom, if I remember correctly. So when we scale this guy now, no, it was not bottom. It was the other way around. Front. There we go. So, and when we change the Z scaling by the amount of the percentage, we're gonna create a small clipping node. The clipping minimum input is 0, the maximum input is 100, and we have the Z here, and the input goes there for battery. There you go. So, and the battery you should read like 33% or something like that. I'm pretty not sure. 74. Ah, yeah, I charged it. So that's 74%. So this is an easy way to create a battery indicator. And yeah, so I did for another cool scene I created a long time ago with Ventus 5, where you had flashlights available, so you could use a flashlight. And inside, you could look inside the flashlight and you see small batteries, 2 small batteries inside, with some bubbles popping up like acid bubbles. But you could see the indicator of the by the batteries for the charging level of the controllers, and that was quite nice. It was a nice gimmick. The same goes for switches and so on. I'm gonna show you that scene later on. So, touch interaction with another controller. So I'm gonna grab my secondary controller and create quickly the Wi-Fi tracked controller with IDs 1, is it? Yes, this is ID 1. There we go. Yeah. We want to have the draw ray, the touch ray. Yeah. Draw ray only untouched. Okay, sorry, because this is ID 1. Like I said, don't forget to have it. So, and then we can have a look at my picker here. Does it work? It doesn't work in this case. No. Need to find that and to click that correctly. Or did I disable that? Because of the headset, I'm using the FreeFly camera. I cannot touch that. So anyway, but this is how you would use then the secondary controller, control the colors, clicking on the buttons for the menus and stuff like that. That's quite easy. We're gonna use that in the other scene I've created. So let's move on. Any questions so far? Please post link to OneDrive. Thanks. For sure, I will do. Yeah, this is quite handy to have this increase and decrease thingy based on the clock. No more questions so far. So you can raise your hand. You can drop the questions anytime in the chat if you want to. And I'm going to take time to answer your questions there. Feel free to do so. Don't worry, no one else can read that if you send it directly to me, but I will answer that in the public and I will not tell your name. So everything is really confidential here. Anyway, so I'm gonna open my particle panels moving wall. Yeah, that one here. This is the scene I sat down for some minutes, and let me put my headset on. Usually the other way around. First the headset, then the rest. So I hope you can see that screen. So I've just my two simple controllers, and I can now click here on the ground. I could. Why it's not working anymore? Is it the correct scene? Let me check. Teleportation works. Let me check. This is my platform, and no, it's not teleporting. Now it's working. Yeah. So wherever I'm pointing at, just a second, I'm gonna change the order of headset and headphones. This is the only thing I really had about the VR stuff. So what you see is I can really teleport to any platform I want to. Move along here, get on top of that platform, having a look at kind of video, which I created here with the particle system. Yeah, this was an advertisement. It's an advertisement video from LG, and the particles changing by size based on the intensity of the video. Yeah, and a small particle room. So all these things are particle boxes. You can also barely maybe see that this ray is also throwing a shadow. So the roof is coming down, cubes are falling down there. But I can move along, teleport myself to the next platform, waiting for the red cube to come up here. I'm now on the cube or on the side of the cube. Hello, I want to be on the cube. Here we are. And as you see, even movable objects are possible in Ventus. So the reason is because I'm using here for each of these elements, I'm using the teleport node. And as long as you click on that specific teleport node, you're gonna get moved to that platform. So I'm here now at the beginning, and you can go up the whole way until you reach that there. And then I want to have usually a trigger to trigger that red platform here. Then you could move to there, touch a trigger and play back the video. That was the intentional idea about this scene. But I'm gonna show you now how I use the teleport node. So get rid of the headset. So there's the first question. The second question coming in: which parameters are actually changed when teleporting some camera offset? Would like to get that and eventually feed that into something else. Yeah, that's correct. The camera offset gets altered, and therefore you could also use either the camera node or the tracked HMD device. So here, and there is a matrix. So this is a matrix of the headset, and whenever you are moving, the values are changing accordingly to your position. You can use set and get the world parameters, and therefore make use of the coordinates. This is the basic idea behind. So world, as you see. So hope that answers your question. Because I was using all these informations to feed that to a secondary machine and have the secondary machine visualizing not only the HMD. I was creating with a guy from Glare a long time ago, and the so-called Elite House, a two-player game where we both could work in the same world and throwing cubes at each other. So I could see his handles, his controllers, his HMD, he could see mine, and also we could use the same cubes and boxes and stuff like that. That's really useful to have then all these matrices available. So when it comes back to using the teleportation nodes, the thing is, which is important, is the order of the teleportation node in first. When you are using a moving platform, for example, like we have here with the, where is it? The one red cube here. This red cube, for example, here it is. It has a constant mover. So it doesn't matter if it's a mover or something else, as long as these X, Y, Z rotational parameters and so on are changed, and we are using the touch teleport behind that, it means that we apply our position on behind that axis. So if I gonna use that position of that cube right now, of this axis, and you would also change the rotation for it. And imagine we stand here on top of that and I change the rotation. My camera view will also rotate with it. So you can create upside down games and stuff like that. Beware. I've seen people puke a lot when doing such fancy stuff. You could also rotate them left and right and create a shaky effect and stuff like that. They're gonna drive crazy, I tell you. So the point is, if you create these touch teleport node behind the axis controls the position of the user. We have several options for this teleport node. The one is the intersection type. Then we have the touch group filters, which are important if you want to use just one of the controllers for such a teleportation. Yeah, because else if you're using the secondary controller, it can also happen that the secondary controller array may hit a surface and then you teleport to that. So it's sometimes better to keep control over that and say only the right-hand controller or the controller number 2 is possible to do teleportations, or the first one, whatever else. And the other one is just for touch interactions. Another important thing is a bounding volume or mesh, and it's really like you read that. When you have a complex mesh like the Stanford Dragon or something like that, you can teleport by using the mesh intersection type. You can teleport on the tip of the tail, of the head, on the teeth, or whatever else, or in the food and stuff like that. If you're using just the bounding box, it will use the bounding box, like 6 simple sides. That means, in fact, the performance is having an impact about this intersection type tests. Keep that in mind. I'm using now a 980 Titan 980 from NVIDIA, a very, very, very low card. Still, everything is possible with that, but well, if I would do more and more stuff, I would nearly hit the border. So nowadays, it shouldn't be a problem with the 2080 Ti or something like that, or RTX, but as I say, But keep that in mind that all these things, especially when you have a lot of these teleportation nodes available or used in the scene, these intersection ray tests may have an impact on the CPU or our GPU. So touch group filter I explained already, and then we have here the last option, which is called ray intersection. The ray intersection is a simple thing. Let me show that on the basic platform. Basic platform means we have just a rectangle here, yeah, or a cube, a flat cube. It's a really flat cube, really flat cube. So my boss controllers, I'm using the headset now. So hold it here, and we have our boss controllers. And when I'm clicking on a point or a position, you may see that we are teleporting around that platform. Yeah. So I have set this teleportation now to the mesh mode. That means when I click here in this area, when I click here, our HMD got teleported there. If I click there, my HMD got teleported there. But when I'm using the ray intersection, even on the mesh, then we get just teleported to the center of the selected or ray hit surface. That means if you have a complex mesh, you always get to the center of the surface, which is, or the polygon, where the ray did hit. So keep that in mind. So if it's a very low poly model, you just have, for example, 16 intersection points. And if you're using ray intersection, you can teleport anywhere where you want, not only on the 16 points. That's what I wanted to explain here. Yeah, so this is very important to keep in mind. Back to that scene. So for the wall parkour, I selected to have the ray intersection mode and have it mesh based, because as you see, when we have a look at the bounding box is here, this size over there, there, and there. So basically I would be teleported always here in the middle whenever I would use now the controllers. So since I want to have it mesh detailed intersection, I have to select it, and then we are able to teleport from for the whole area around. You could also try to use several planes and just create a surface of that. If you really want to save the intersection points and stuff like that, I would prefer then, instead of using the whole mesh, I would use just the top polygons, select them in my 3D tool. We call it extract in 3ds Max. I would extract that one or detach them and have just a simple planar polygon snake where we can teleport to, so that whenever the ray also hits the lower part, it will not move myself onto the lower polygons. It just has a surface of polygons where it can go to. You cannot click on the sides like I did with the cube, for example. The whole cube was taken as a touch intersection object, and therefore I was sitting here during the showcase we had some minutes ago. So just try to use planes and flat geometries to teleport on, just as a side note. As you see, all of these REST platforms and so on are really using the basic stuff like mesh and ray intersection, and for such an easy and yeah, let's say low polyish room, that's fair enough. Or if it's more high poly detailed, then you should concentrate yourself on creating areas where you can teleport to by planes or by creating very simple geometries. If you want to have a look at these things, I have created a scene, the interactive touch scene in there and there, and this is really basic. Like, you have a start point, you can teleport to there, and to there, and then you have one moving platform. The whole scene is very slim. It should give you enough idea how these things work in the end, and the controller has also the possibility, by using the side buttons, the grip buttons, to change between limited parabolic ray and infinite ray, but it has not the functionality to make use of the limited ray in a way that you can use the D-pad to control the range of it. Yeah, just as a side note. So we have another question popping in. Let me read through. I noticed that teleporting is moving the point on point 1 touch to the middle of the room 1 had defined in Steam, not the headset. Is that still like that? Yeah, you are moving really, whenever you're teleporting, and that's an issue we have with the OpenVR stuff is you are really teleporting the room. The whole room gets teleported to that position. That means the actual center of your space you have measured in the Steam VR room setup. There is an origin, and this origin is the translation point where you get translated to. Dirk, a programmer of us, is aware of that, and he tries to solve that we have the same behavior like in the lab. They are interpolating to exactly the position you see the footprints on the ground where you are going to teleport it at and teleport it to. Yeah, we are aware about that. I really would like to see that feature also come into. This is, for me personally, very important because it is more or less like you can drop through the walls, and that's kind of sad. Yeah, that's true. So that's a really bad thing. But like I said, we are aware about that, and we're gonna need to change that. That means when one is sitting away from the center of the defined room, one cannot teleport exactly to where one wants. Yeah. And that's the problem we have because of that situation. That's true. What you could do is, if you have a spectator watching that, yeah, by using the get and set world mattress stuff, you could measure your room and estimate, okay, he's sitting like 2 meters to the left and 1.5 meter to the back, and apply that to an axis so that he is always in the right position. But like I said, this is so dynamic, it's nearly impossible to do that. Let me think about if it's possible with a Chrome. I think it's way too complex to do that in Logix. We should really wait for a solution coming from us. That makes no really sense. So you could use a tracking crown and track this position and use the difference between the room center and the track crown position to compensate that. But this is way too off, I would say. Yeah, we have a lot of more things which we can do with these whole thing. Let me see if I have something prepared here in this project, but I hope so. No, this is just the past. So let's move on to another project, the old one I did long time ago for internal use. I think we never ever released that scene. There it is. Yeah, what you can use with the VR glasses is also all the IBL post effects, like having glows or using the image-based lens flares. The good thing, it's like the traditional old school style stereoscopic rendering stuff we had with the ELSA Revelator glasses and so on. I don't know if you remember these times, but I'm coming from that times. Where you have the shutter glasses and stuff like that. DirectX has the possibility to render 2 cameras, and it was quickly switching between these 2 cameras then by using a driver functionality. So it switches from the left to the right, left to right, left to right, and therefore the IBL post effects are working correctly inside of the VR headset. So that means whenever you using IBL effects, like using here lens flares, they're gonna show up correctly in the glasses. The same goes for the massive glow I was using here. That's the reason why it's absolutely only for internal. This scene is so massively overloaded. So let me put on my headset again, just a second. So we will have short hiccups because of loading areas and stuff like that. Just a second. We have changed so much that you can't even use my controllers anymore here. Yeah, this is a simple controller I was creating. You could switch by using these side buttons through the rays, like limited volume, infinite ray. By using the upper button, you could fade in a menu. Then you could use these controls to change the colors for flashlights and painters and so on. As you see here, so stuff working. I could quickly change to the standard tool, disable flashlight, or use a custom flashlight. And here's my flashlight, which I meant in the beginning. I wonder why I'm not having the batteries shown up correctly right now. Anyway, so we see Ventus was loading. So disable the flashlight, standard controls, and I could move through the platform here quite easily. The whole train was created when we first had Substance Painter available. We could enter the train. Yeah, mind your head. So use the flashlight. Look around. You could also widen up the flashlight by using the trackpad controls. You could lower the intensity or the range of the flashlight, as you see. Shadows were possible, and then you could change where to go. Let's go for my shadow games. And you see the train is now moving to that destination. So whenever you move, you see here shadows inside and stuff like that. That was one of the first heavy scenes I created with VR. Open the door, we get out, and you can toggle this area. So let's get for the custom flashlight. And as you see, I can use my flashlight. We have a video in the background. I could make that guy smaller and the shadows are working. So it was a quite nice idea to have a simple flashlight. That was intentional. You can change the color for the flashlight to reddish, and everything is now in red. Yeah, that was the basic idea with it. Get for the standard tool, back to the train. Getting into the train. You don't need to worry to close the door. It will do that automatically. And you go for the browser. Open the doors. Get out. Don't tell me it's bright. And as you see, we have now here a virtual keyboard. And whenever you hit the correct letters, it will highlight up the stuff. You can type in stuff. And you can go for a Google search. I should use the infinite one. Then we hit close. You can go for search. No, my lighthouse is not working here. So all these things are really working in a huge web browser, which is quite funny, I would say. Yeah. So much about the possibilities. Oh no, we have something else. This is a paint on black. Not painted black, it's paint on black. Come on, we are there. Paint on black. Because you're using the right D-pad buttons and you can rotate the menu. So we have infinite ray, limited ray, volume, eraser on or off. So I want to turn off the eraser, and we have a laser pointer. We can draw with a laser pointer on screen. We have a spray can. By the way, this shows how much the can is filled. And then you can use the spray can. You can define to have a bigger brush size. I can make it smaller and tiny. You can change the colors to have it yellowish or reddish or whatever else, or purple, and draw on top. So as you see, I've customized these controllers a lot. It was a hell of work. I'm gonna show you now the train comes back ultra fast. I'm gonna show you now a bit of how I did that, especially how to create custom graphics or custom textures. Just a second. So let's get back to the logics. To have these menus created or these controller menus created, it's quite easy from outside. When you have a look inside into the left-hand menu, this is the controller menu. We have a bit of fancy rectangles with nice hexagonal colors. We have a touch button for each color for the pre-selection, for example, for the spray can or for the laser pointer. So in the end, this is quite easy. We have here the color picker, which are reused in the other scene. Then we have a custom model imported for the spray can, which is on the right-hand menu. So basically, this is quite easy to create such a menu, but it's a hell lot of work for all the bindings, to have all the triggers and buttons assigned and stuff like that. So here's no, the battery is not connected. That's the reason. So yeah, that's a lot of work to create such a nice controller. This is for the tools. So I used a different kind of track controller units because of the different touch groups. Yeah. You could change them by using custom verbs or whatever else, but that was a long time ago when I was kind of newbie for Ventus, so this was the only way for me to solve that problems I did face. And yeah, that's how I created the controllers. So here we have the analog X and Y ranges. You see these containers popping always in to increase or decrease ranges, especially for the cones, for the range, for the length of the ray and stuff like that. So this is very helpful to have this ray length container available. And then we have the train, which stops on different kind of states. Yeah, and the same goes for the flashlight later on, the shadow filter, that we don't have the spotlight effect in the shadow, the controllers or the menus. Inside of the train are some dynamic lights, which should not be affecting the controllers and stuff like that. So that's a lot of things which you need to take care of. So the textures for the controllers. Let's go back to the simple controller. He is here. For now, I'm gonna hide all the rest of it. So we have this controller here. Let's delete them. We don't need them right now. We have the controller here. This is the standard Vive controller texture and the standard controller which we got out of OpenVR of the library because we set it to Vive and therefore we rendered the model of the Vive. And I told you can enable or disable the drawing, but we have also the draw Vive controller, right? So when I disable that guy here, it's still drawn because now the draw node is overriding the rest of the properties. Like we can disable now simple and easy parts of the controller, like the body, like the button, like the grip, like the LED. The LED is sometimes really annoying. That is a good addition we have right now. Let me get quickly a camera in here. I want to change the clipping values. So here, something like that. So, whoop-ah, where's my drive? There is the controller. So, anyway, the the LED status really annoys me sometimes. That's the reason why I then use the draw controller and I disable these things, then LEDs and status. You have the system button, which is the home button and stuff like that, and you can say always draw the point for the D-pad. But another thing is here, use texture. You can say no, don't use the Vive texture, use your own one, or you simply use a material and check for the base color. You see the checker pattern appears on here. Then we have the VR controller textures. Here we are. The point is, these controller textures are to be found in this Steam VR SDK directory. I'm not pretty sure where exactly to find them because we have a support for 20, 40 controllers, something like that. You really need to use Google in this case and check where you're gonna find the correct Vive controller texture. But just to show you that quickly, the mapping is always the same for both controllers, and you have like how to call that, a template. It's more like a template, and then you can just colorize the stuff and change and adjust these things and draw your own stuff or draw your own letters of text on it or have your branding for a company or something like that. And whenever you load that texture, you see it's immediately applied to that. So when using no light, you see now this controller is basically using the texture. Let me see if I can simply scale that guy up. So this is so annoying with the camera clipping. So here we go. So there you have it, and then on top you use just an emissive, for example, emissive texture, which is the glow. Yeah, same font, and this emissive goes about 10,000. It should be HDR. It's not working right now because of it's using still the texture, right? Yeah. So here we go. This is the controller I used in the train example and also in the rest of the examples I've shown you. So in these textures really match the controllers. Okay, the text is duplicated and I see it's mirrored on the other side. So therefore you can create your custom designs. You can, like I said, disable parts of the controller as well. You can have your own models for that controllers, like I did with the spray can and so on. These are so the basics of all the VR stuff we have available now for Ventus. The same counts, by the way, if you're using the Oculus controllers. So let's see if we go for the Oculus, but I doubt it will show up because we don't have an Oculus connected. Yeah, it checks for the ID if it's a true ID, and therefore we don't see now the Oculus controllers. But anyway, so this the same applies later on for the Oculus. The bad thing about all that is, as you see right now, you cannot simply switch on the fly between both controllers. You need really to have both cases available in your scene. That means whenever someone is using an Oculus Rift, you should have prepared all the buttons and all the controllers, all the mappings, all the textures for the Oculus. And the same goes if you want to support the Vive, you would need to do the same for the Vive controllers. I know this is a bit of pain in the ass, but I'm pretty sure whenever you're using Unity or Unreal, there is a lot more to do than only that. For prototyping and so on, as you know, Ventus is the tool to really get fast to a to a good result, to showcase things, to draft things. And first, I hope you enjoyed that VR session. If you want to have more information, just drop me a line. write something down in the forums or visit us at Discord. You can PM me there or whatever else. I would be happy to answer your questions. If you have some questions left, please ask them now. I'm here right now. I can show you things. Later on, I'm not. I'm just in the forums. I'm just in Discord. So take a chance. If you have any questions, feel free to ask them right now. The 3D touch simulator seems to not be moved when teleporting. Is that right? That is right in first, but I will have a talk to one of the developers if it is intentional. I had the same question long time ago, if I remember correctly. Yeah, since I wanted to have that really as a simulator, but it should move along with the HMD. So if that's not the case, please drop us a line and we're going to have a look at this. Okay, when there are no more questions, thanks for joining this webinar. I hope you enjoyed that. As I said, it will take around a week or sometimes 1 week and a half until we publish the YouTube video. I hope you enjoyed that, and yeah, see you soon. There are some more webinars coming up, so subscribe for them if you want to. And have a great day and stay safe. Thank you all. Goodbye.